Polar Equations, Part 1, Polar Coordinates. When we want to find a point in the plane, there are different ways of describing its position. In rectangular coordinates, we use the point x comma y, where x is the distance that we go along the x-axis, and then the y says, now, how far do I go along the y-axis, or parallel to the y-axis. In polar coordinates, we can describe that position in a different way, using r and theta, where r is the distance, in quotes, from the origin, and theta is the direction that we go. Notice that polar coordinates is really right triangle trig. So when you're stuck in polars, whether it's pre-calculus or calculus, very often you're going to want to come back to one of these 5 things. First, the 4 main equations. X is r cosine theta, or x over r equals cosine of theta. Y is r sine theta, or y over r equals sine theta, of course. And then tangent of theta is y over x. And of course, the Pythagorean theorem, x squared plus y squared equals r squared. The 5th thing is r. So r is the, and I'm going to put it in quotations, r is the distance from the origin. And the reason I put distance in quotation marks is that distance can be negative. Although when I write problems, I try to avoid that situation, not always, but whenever I can, and just make r positive. So let's do some transformations, if you would. Let's start by changing rectangular xy to polar r theta. With one simple example, let's let xy equal the point 1 comma root 3. So what does r equal? Well, r is the square root of x squared plus y squared, which is the square root of 1 plus 3, which equals 2. And theta is the inverse tangent or arctangent of y over x, which means theta is pi over 3. So I could write my point in polar form as r theta equals 2 pi over 3. Now, if you recall from trig, there are many ways of writing a point, but I will just write the simplest point that I can think of to find r and theta. Well, let's change from polar form. Let's say I have r theta equals 2 comma 3 root pi over 4. And I want to change to xy and plot the point. So find the point xy and also plot the point. I'm going to start by plotting the point. And my recommendations when you're plotting in polars, I say start with the angle. So if I want to plot 2 comma 3 pi over 4, I start with the angle 3 pi over 4, which is supposed to be right down the middle in the second quadrant. And then I go 2 units, 1, 2, away. If I want to change to xy, I know that x is r cosine theta. So 2 times the cosine of 3 pi over 4, which is 2 times negative root 2 over 2, or negative root 2. And the y is r sine theta, so that's 2 times the sine of 3 pi over 4, which is 2 times positive root 2 over 2, or just root 2. So polar is 2 comma 3 pi over 4, means our rectangular is negative root 2 comma positive root 2. Now let's plot one other point. I just want to plot it. Let's plot the point negative 3 4 pi over 3. And this will be r theta. Again, I recommend by starting with the angle. So 4 pi over 3 is somewhere down there in the third quadrant. But the negative 3 says go not in that direction, but in the opposite direction. So I go 1, 2, 3, in the direction opposite of the angle, if you would, 4 pi over 3. Let's do 2 more simple problems. We'll start here by changing from polar to rectangular form. And I'll show you a couple ways to do this next problem. So suppose that my polar form is r equals 4. What would the function or the expression, it'll be a curve in this case, be with x's and y's? 2 approaches. One is to understand that r is the distance from the origin. Which says I'm always 4 away from the origin, regardless of the angle. So what shape is equidistant from the origin for all points? A circle, of course. So a circle centered at the origin with a radius of 4, or x squared plus y squared equals 16. What if I hadn't thought of that? Well, then I can go back to my 4 right triangle trig equations, the 3 with Pythagorean, and notice that if r equals 4, then r squared is 16. But I know that x squared plus y squared is r squared. And I arrive at the same answer. So what if I want to change from rectangular to polar? Now I'm just doing a couple examples. Let's do x squared plus y squared equals 2y. But for almost everything, when I'm stuck in polars, I go back to my 4 equations. So let me write them one more time. based on right triangle trig. X equals r cosine theta. Y equals r sine theta. X squared plus y squared equals r squared. And then tangent or arctan of theta is y over x. So tangent of theta is y over x. Let me fix that really quickly. Sometimes my brain gets ahead of itself. Theta is the arctangent of y over x. So how could I change this one from rectangular to polar? Well, let me just look over here and see if there's anything that helped me. Of course, we already talked about how x squared plus y squared equals r squared. Well, how about the y? Well, y is r sine theta. Now, in rectangular, I wouldn't recommend doing this. Generally speaking, if I have an equation, I factor things out. I don't divide things out, but I often make an exception for polars. So if I take an r out of both sides, I end up with r equals 2 sine theta. So x squared plus y squared equals 2y is equivalent to r equals 2 sine theta.